Good morning, my friends of class 10th. I'm making this video just for a purpose of quick revision or the purpose of recapitulation, and these will be very small videos for a small duration, and each topic will be dealt separately. Okay, so these can be used for revision purpose as well as these can be used for the first time learning also. Okay, the chapter is current electricity and the very first topic in this is electric charge. See, you have been studying electric charge in your previous classes also, and you know that every atom is made up of three different particles. What are these three particles? Protons, neutrons and electrons. And out of these particles you already know that protons are positively charged, electrons are negatively charged, and neutrons, they do not carry any charge. Okay, so what is this? First of all, what is this thing called electric charge? How do you define electric charge? See, in this world, all the electrical phenomena and all the magnetic phenomena that exists, it exists because of this particular property of particles which is known as electric charge. Okay, so if charge vanishes from this world, you will not be able to observe two things. One is the electric effects and other is the magnetic effects. Yes, you heard it right. If electric charge is supposed to be vanished from this world, there will be no phenomena of magnetism also. Okay, see, when you turn the fan on, when you switch the fan on, the fan starts moving. Okay, what are these effects? These are the electrical effects. Electrical energy is getting converted into mechanical energy. When you switch on a toaster, the electrical energy is getting converted into heat energy. That is also what? Included in electrical effects. Okay, now if you switch on an electromagnet, its magnetic field starts to develop around it. Okay, when you switch it on, it will behave like a magnet. When you switch it off, all the magnetic phenomena will vanish. So what is this effect? This is the magnetic effect. Okay, so from here we will be defining what is electric charge. For the proper definition, you have to refer a book or the notes. But this is a video just to give the idea that how the definition of electric charge is made. Okay, so now see, because we know that electric charge is responsible for two phenomena. One is the electric phenomena and other is the magnetic phenomena. So we will define electric charge on the basis of these two. So how will we define it? Listen carefully. It is the property of particles. Electric charge is the property of particles due to which electric and magnetic effects are observed. I am repeating it. Electric charge is a property of particles due to which electric and magnetic effects are observed. Clear? Very simple definition of electric charge. Okay. Now it comes to measure electric charge. See, if you cannot measure anything, you cannot use that thing. We can use only those things which can be measured in mathematics. So can we measure electric charge? Yes, we can measure electric charge. And if we measure that electric charge, which unit we will be using? We will be using this unit which is known as coulomb. The unit of electric charge, the SI unit of electric charge is coulomb. Coulomb is the name of a person who did some initial research for electric charge. So the unit of charge is defined in his honor. Okay, so what is the SI unit? It is defined in coulombs. And now if I want to know that what is the charge present on one single proton, what is the charge present on one single electron? It was measured experimentally and it was found that the charge of proton was, of course you know it is positive, but what was exactly that charge in numbers? In numbers it was 1.6 into 10 to the power minus 19 coulomb. You can see how small is that number. Okay, I have written this in scientific notation. You are also supposed to learn this charge in scientific notation, but if you write it in without scientific notation, it will be 0.0000 followed by 18 zeros after the decimal. So what exactly is the charge of proton? It is 1.6 into 10 to the power minus 19. That means it is very, very small in magnitude. Okay, similarly, what will be the charge of electron? It will have the same magnitude, that is 1.6 into 10 to the power minus 19 coulomb, but the sign of that will be negative. Why negative sign? Because protons have positive charge and electrons have negative charge. Now again see, this positive charge of proton and negative charge of electron, they have got nothing to do with mathematics, they have got nothing to do with the emotions. What does this plus and minus charges on proton and electron, they verify? They just verify this thing that protons and electrons, whatever charges are on them, the nature of charge is opposite. Okay. If you put proton and electron in in the same situation, all right, what I mean to say is, if you are putting one proton and one proton into the same type of environment, then if proton moves towards one side, the electrons will move towards the opposite side. Okay. If proton starts moving in clockwise direction, electron will start moving in anti-clockwise direction. What does this show? That the nature of charge on proton and on electron is mutually opposite. So we can symbolize this opposite nature by using some words also. We can call them north or south, we can call them east or west, we can call them multiply or divide, we can even call them black and white. But the most simple notation we are using just to depict that their nature of charges is opposite. So we are calling proton as positive and electron as negative. Okay, nothing to do with mathematics, they just simply show that the nature of charge is opposite. दोनों का नेचर अलग होता है, बस ये बताने के लिए एक को प्लस कर दिया, एक को माइनस कर दिया. Right? Now, coming to this, see. If the charge of proton is very less, or electron is very less, 1.6 into 10 to the power minus 19, so small, then how many protons or how many electrons will be required to make 1 coulomb charge? How many protons or how many electrons will be required to make 1 coulomb charge? So if I want to know that, I have to use some mathematics. Okay, so what should I do? See, if I have 1 proton and the charge on it is 1.6 into 10 to the power minus 19, then how many protons, n number of protons, how many protons do I need if I want to have 1 coulomb charge? Okay, 1.6 10 to the power minus 19 coulomb is for 1 proton. Now I need 1 coulomb charge, so how much number of protons I will be needing? Just make a cross multiplication. Okay, 1 multiplied by 1 coulomb and n multiplied by 1.6. So how to find the value of n? It will be 1. It will be 1 upon 1.6 into 10 to the power minus 19, and which gives you a number 6.25 into 10 to the power 18. Okay, so these many large number of electrons or protons I need if I want to have 1 coulomb charge with me. How many? Just see this, 6.25 10 to the power 18. If I speak this number, it will be 6250000000000000000 number of protons. Okay. This was the definition of charge and the basic nature of electric charge.